A lot of times we have an equation that we need to solve that initially isn't a quadratic equation. It doesn't look like one. But we can make a substitution that will create a quadratic equation that's related to the original that we can solve. We do have to check all of our solutions, much like what we were doing with rational and radical equations. So these equations are called equations in quadratic form, which means although they may not be quadratic, they have a pattern that the leading exponent, taking a look at number 1, is 4, and then the next exponent on the variable is half of that. So 4, 2, and then the last term is constant. Looking at number 2, we have x to the first power, and then the next x term is really x to the 1/2. Remember, we can take those radicals and turn them into rational exponents to the 1/2. So we have that same pattern where the first term's exponent is double that of the second term's exponent on the variable. I can scroll down and look at some more problems in our worksheet. Notice in number 4, we have x to the 2/3 and then x to the 1/3. Again, the higher exponent is twice that of the next exponent on the variable. The exponent 1/3 is half of the exponent 2/3. Similarly here, even though we have rational expressions, we still have that same pattern with the exponent on the x's. This is what we mean by equations in quadratic form. So let's do one together. Looking at the first equation, x to the 4th minus 8x squared minus 9 equals 0, we can see that it's a 4th degree polynomial, but we can also see that the first exponent 4 is twice the second exponent 2. This is leading us to think maybe this is in quadratic form. So let's do a substitution. We're going to use u for our substitutions because u is not a common variable that we tend to use in algebra, and so not using a common variable hopefully will remind us that we need to go all the way back to x to get our answers. So if we make a substitution, u equals x squared, I'm going to do this over to the side. We have x to the 4th minus 8x squared minus 9 equals 0. If u is x squared, then right here next to the 8, I can make that substitution where x squared now becomes u. Looking at x to the 4th, notice that if I square x squared, I get x to the 4th. So this x to the 4th out front is really u squared if we make that substitution. Minus 9 equals 0 comes down. That doesn't change. We don't have any x's in there, so we don't have to worry about that. And now we have a quadratic equation. We can use the quadratic formula. We can use completing the square. In some cases, we can use factoring or the square root property. And it turns out for this problem, we can factor it. And you can see the factoring right here in the substitute column. Substitute, then solve for u. And we get 2 answers for u. As we should. The equation with u in it is quadratic, and that square, the degree, tells us how many solutions we have to the equation. We have 2. But that's not the equation we're trying to solve. The equation we're trying to solve is x to the 4th minus 8x squared minus 9 equals 0. So we're not done when we get an answer for u. We have to reverse the substitution. If u equals 9 and u equals x squared, then x squared equals 9. And if u equals -1, then x squared equals -1. And we reverse the substitution because we're solving for x. That's our goal. We started with x's, we want to end with x's. Or whatever variable we start with, we have to end with that variable. Noticing that reversing the substitution, x squared equals 9 means I have x equals plus or minus 3. And then x squared equals negative 1 means I have plus or minus I. And then we get 4 answers. 4 solutions to an equation of a degree 4. Yay! Okay, let's walk through one together that's not already worked out for us. X minus 11 square root x plus 30 equals 0. The first step is to decide how to substitute. If the equation is written in descending powers of x, that means our highest power of x is first, and then our next highest power, and then our next highest power. If we're written in that way, looking at it this way, x to the first minus 11x to the 1/2 plus 30 equals 0, where the constants are always at the end. It's written in descending order, highest to lowest powers of x. Then my substitution, I want u to equal whatever the second term's variable is. So I want u to equal x to the 1/2, or the square root of x. So u is the square root of x. If I do that, I'm going to use the bigger box over here because I have more room. X to the 1/2 becomes u, 30 stays the same, 0 stays the same. Notice that if I square both sides of my substitution equation, u squared is x. So that means x becomes u squared. And again, I have that quadratic equation, u squared minus 11u plus 30 equals 0. Since we have a quadratic, we can use our quadratic solving techniques, quadratic formula, completing the square, possibly factoring. And we can try factoring because factoring tends to be the fastest of the solving methods. Or we could try quadratic formula because it always works. It's really up to you which method you want to use to solve. So I have u squared minus 11u plus 30 equals 0. If you need more room, pull out a piece of paper, write on the margin, stick it on the back. I know these boxes don't tend to be very big. You're welcome to write it on your own paper if you need more room. We could use the quadratic formula, so I'm going to try that here just to be different to show you that it'll still work. Instead of x equals, though, for the quadratic formula, I'm going to use u equals negative b plus or minus square root b squared minus 4ac all over 2a. And I can see that a is 1, b is negative 11, c is 30, and plug those in. Negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. We'll make it a little bit bigger. Sorry for the line in the middle. 11 plus or minus square root negative 11 squared. Negative 11 squared will be 121. Minus 4 times 30 is 120. Oh, that's going to turn out nice. 2. 11 plus or minus square root 1 over 2. And then if I simplify this, square root 1 is just 1. 11 plus 1 over 2 will give me 12 over 2, which is 6. And 11 minus 1 divided by 2, 10 divided by 2 will give me 5. So I have two answers for the quadratic equation, u squared minus 11u plus 30 equals 0. Now I have to take these two equations, because this is u equals 6 and u equals 5, and I have to change them back to x equals. So I'm going to block off a little room there. U equals 6 and u equals 5 means that I really have square root x equals 6 and square root x equals 5. And now I can solve for x. Square root x equals 6, so x is going to equal 6 squared, which is 36. And square root x equals 5 means x equals 25. Oh, means that x equals 5 squared, x equals 25. Now, the equation we started with the square root in it is not a polynomial. So it does not follow the same rules as the previous one, that the degree on the polynomial tells me how many solutions. This is not a polynomial, so those rules don't apply. And we still have to check all of our answers. So, checking them, we're going to plug in 36 and 25 back into our equation one at a time. 36 minus 11 square root 36 plus 30 equals 0. Does it? 36 minus 11 times 6 plus 30. 36 minus 66 plus 30. And 36 plus 30 is 66. Minus 66 is 0. The 6 works. The x equals 36 works. So we will keep that one. Now we need to check 25. 25 minus 11 square root 25 plus 30. Does that equal 0? 25 minus 11 times 5 plus 30. Does that equal 0? 25 minus 55 plus 30. And then 25 and 30 is 55 minus 55 is 0. And that works too. Hooray! So we have two solutions. X is 36 or 25. This notation, we haven't really used it very much, but it is our solution set. Solution set is just a set of the numbers that solve the equation. It's a lot like set builder notation, which you may have seen for inequalities. But you can also write it as x equals 36, 25, or x equals 36 and x equals 25. Any of those are acceptable for me. Follow the instructions on the homework so that you don't get counted wrong, even though it may be a correct answer. You want to make sure you're entering your answer in the way that you're being asked to enter it.